Hello everyone in virtual section. This is Yuhao from Shanghai Tech University. The paper title is Distance Protection with Dynamic Trip Region for Lines Terminated by Inverter-Based Results. This research is supported by CIPES and Power System Protection and Automation Laboratory. Let us move to the first part. Renewable energy power generation are connected to the grid through inverters, called inverter-based results, or IBR. However, the output characteristic of IBR is different from synchronous generators. The future of the latter one is the basis of classic fault analysis and relay design. Earlier researches and fault cases have shown that traditional distance protection methods may malfunction, especially in high-resistance fault, after IBRs are connected. To explain this phenomenon, let us review existing distance protection methods. Consider a classic two-terminal transmission line model, a circuit break at terminal G. The basic principle of distance relay is the apparent independence is composed of line independence and fault resistance corrected by coefficient Z and the coefficient I. For traditional grid without IBRS, the apparent independence equation is as follows. Based on homogeneous system assumption, the phase angle of the coefficient Z and the coefficient I are both small enough, which means the additional independence caused by fault resistance is purely resistive. Thus, a quadratic region is designed to achieve the protection such as the figure. However, the IBRs do not have the moment of interior, and its output is determined by controller directly. IBR behaves as a controlled current source. That means it doesn't not follow Thevenin equivalence. For existing distance relay methods, the angle of the two coefficients are no longer to zero, and it's hard to estimate it before fault occurs. A simulation result shows the zeroth impact. As the fault resistance increasing, the apparent independence will have a large imaginary part. Traditional distance relay methods using circle or quadratic region cannot detect high resistance fault correctly. This is a serious hazard. To solve this problem, we need to revisit the fault circuit analysis. Fault current can be estimated using fault sequence network analysis. We can express apparent independence without local terminal independence. The result for all kinds of fault is shown in the right table. The coefficients in the IBR side without ZG is more complicated than in traditional grids. With fault resistance M and fault resistance RF are unknown. If coefficient I and coefficient Z can be tracked in real time, the impact of fault resistance will be greatly mitigated. This provides the way to prove the relay performance. A method with dynamic trip region is proposed so that the quadratic region rotates downward accurately. I will describe this design in detail in the next slide. To build the dynamic trip region, the first step is to select the maximum protection distance and the maximum fault resistance. Then, a fault in protection range must have value M from 0 to maximum protection distance and a value RF from 0 to maximum fault resistance. Thus, the range of coefficient I and coefficient Z can be updated according to real-time measurements. A quadratic region is generated and adjusted through boundary condition, which is shown as this table. In fact, boundary 1 to 3 are straight line, and boundary 4 can be approximated as a straight line. The workflow flow of the distance protection elements is shown in the right side, which is similar to the classic independence method. The main difference is the left batch, about updating the dynamic trip region based on boundary conditions in real time. Numerical experiments were carried out by MATLAB and Simulink. An inverter-based results based on PQ control is connected to the local bus, and the length of the transmission line is 50 kilometers. The maximum trip distance of Zone 1 relay is set as 80% of the line, and the max trip resistance for a single line to ground fault is set as 200 ohms. The first case will explain how the trip region is dynamically varying over time during the fault. A 100 ohms A to G fault occurs at the 15% of the line length and at 0.1 second. Figures on the left shows the dynamic trip region and the apparent independence varying with time. The trip region is a straight line before fault occurs. During the fault, the quadratic dynamic trip region is generated and adjusted. The corresponding apparent independence enters the dynamic trip region at 22 milliseconds after the fault occurs, and stays in the trip region since then. We can notice that the independence after reaching steady state still has an imaginary part that far exceeds the line independence, which means traditional method with a fixed region, such as circle or quadratic region with 5 degrees downward sloping, cannot detect the fault in protection range. A series of faults are tested in the same system. Both of them are A to G faults at 0.1 second, including different location and fault resistance. The result is shown as the right figures. The left group is the low resistance fault. Proposed method can detect faults in the protection interval within a circle. Existing relay methods have similar performance in low resistance faults. The right group is the high resistance fault cases. Proposed method can detect faults in the protection interval within 2 circles, where traditional method cannot detect the fault correctly. For the final 2 cases out of zone, the trace of the apparent independence does not fall into the trip region and will be taken care of by Zone 2 relay. These cases show the excellent selectivity of the proposed method. To sum up, proposed method can detect faults within different fault resistance, which improve the reliability compared to traditional distance relay. Let us summarize our research. Due to the controlled source characteristic of IBRS, the traditional distance protection method has problems, especially for high-resistance faults. An improved analytical expression of the apparent independence is present, which considers the equivalent independence of IBRS is not fixed. The main contribution is an improved protection method based on dynamic trip region, which can eliminate the influence of the ground resistance. Numerical experiments proved that the proposed distance relay with dynamic trip region can improve the reliability compared to traditional methods. Further improvement of the proposed distance relay and the possibility to expand similar ideas to other types of systems will be studied in the future. That's all. Thank you.